Okay, so today we're talking about odd, even, or neither functions. And first, let's review a little bit of what you've learned so far. Domain. Domain is denominator and square roots. Is there a chance that this is going to have problems with its domain? Yes. You have to watch out for certain things. You have to have this part be greater than or equal to 0. That's how you do square roots. And this part, how do you write that? Not equal to 0. The denominators you don't want to be 0. This is totally different than that is. Because the one of them, it's okay to be 0. It's okay to be 0 in a square root. It's just not okay to be 0 on the bottom. So if I write out the two things, I know we've done this problem before, but just trying to review the process with you. You say x is greater than or equal to 0, and then for this one you say x minus 2 not equal to 0, x not equal to 2. Then you make a number line. Then what do you do once you got this part? You check. You check spots. And you see, okay, does 1 work or not? You stick it in. Now, some kids get confused on what am I looking for? What you're looking for is, does this cause a problem, which would be a negative under a root or a 0 on the bottom? Does it cause that? No, so it worked. So it works in here. Does it work at 0? Well, I could just look back here, or I could just try 0. Stick in a 0. See if it works. Does it work? Yeah, even though it's a 0 on top, that's okay. It's just 0s on the bottom that are a problem. So that works. So 0 works. And does 2 work or not? Well, I try it. I stick it in here. Does it cause a problem? Doesn't cause a problem on top. Does cause a problem on the bottom. Can't be 2. Then you check things like 3. And does 3 work? Yeah, 3 isn't a problem. So it works out there. Does like -1 work? Nope. As soon as I put a negative under the root, won't work. Doesn't work. Okay, so that's how you do domains. Should be good at those by now. Shouldn't have to be reviewing this, but I like to review. I like to keep it in your mind and make it really stick. You know that commercials, they find that you don't really remember a commercial well until you've seen it 7 times. That's why you get bombarded with some commercials over and over and over again, because advertisers have learned that it takes 7 times before something really sticks in your head. So there's the commercial you saw once. It'd have to be an amazing commercial if you still remember it once, after seeing it only once. All right, moving on. Local minimums and maximums. Does this have a local maximum? Do you see it? Stare at it. Are you staring there? Good, that's the local maximum. Now, there's other spots that are higher than that, so that is not the absolute maximum. Now, if this has a little arrow on the ends, I should clarify. That means it goes up forever, and therefore there is no maximum, ultimate maximum. There is a local maximum, but no absolute maximum. How about an absolute minimum? Is there one of those? Yes, it's down here. And then here's another minimum. Now, kids get confused by that. Those are both local minimums. And this one's a local minimum and the absolute minimum. Okay? All right, next part is where it's increasing and decreasing. It is increasing anytime it's going up when you read from left to right. So from here to here, for instance, that's increasing. So if I had to say where is it increasing from, I would say from there, which is at -1, 2, 3, 4, 5, -5, to, and it's, notice that's an x number, to the x of this, which was telling me that that is at -3.2. So it's increasing from -5 to -3.2. Do I have to put parentheses or brackets? I'll allow either, because even math teachers argue about it. I think that it should be parentheses, because at the end it seems to me like it's not increasing anymore at that number. It stops increasing. All right, so decreasing, same idea. If I had decreasing from here to here, I'd say it was decreasing from the -3.2 to the 0. All right, the black area there. Okay, that's local mins, local maxes, intervals where it's increasing and decreasing. What degree is this thing? It bounces and it cuts through twice. What degree is that? 4. And then lead coefficient, is it positive or negative? Positive, because it's going up on the right. We don't even care about the left. It's on the right-hand side. If it's going up, then it's positive. That means it starts like this. Positive number there. There's no negative there. Okay, moving on. So how do you find a max on a calculator? This is a new one from yesterday. Would you please type this one in, remembering to use the negative key, not the minus key, and use your calculator to find the maximum of this. And I'll be curious to see if you know whether to give me the x or the y. Would you write your answer down on your paper once you found it with your calculator? I am going to do it too. Now hit graph. Your measures may not look like mine, but you can always Z-box it and zoom in on the part that you want to look at, but you don't really have to. Remember, use second, calculate maximum. Second, calculate the maximum, which is number 4. And now you go to the left of the spot you want, the right of the spot you want, and you hit arrow, go over the spot you want pretty much, and hit enter. Maximum is at -3 for the x, and some of your calculators will even say -2.99999. Mine actually usually says that, but now it happens to work out nice this time. But look at the y. What's that weird thing? Pretty much 0. It means 0.00000000000000144. I might have my zeros wrong on that, but basically you get the idea. It's extremely small, really close to 0, so that means 0. So which is the answer? Is it the -3 or is it the 0? What I asked for was the maximum, which doesn't that sound like the highest? What's the highest this graph went? That's a height thing. That's an up and down. That's a y thing. So I wanted the y number. So your answer was 0. Not the -3. It's the 0. It was at -3, 0, but that's the height. That's the maximum. All right. Raise your hand if you're comfy using second calculate maximum. Good. Moving on then. I told you I was going to teach you about even and odd. So here's even functions. This is a whole bunch of even functions that I found on Google Images. Try typing in odd and seeing what you get when you Google that. You get more than just graphs, let me tell you. Anyway, here's an even one. Do you see how it's got symmetry? So like I could flip this side over, reflect it over that way, and I would have a perfect reflection. You see how that's true on all of them? The hardest one to see that on is this one right here, so I'll show you that it has, oh, the alignment on my board is slightly off, darn it. So it didn't match up perfect, but then when I reflect it, you'll have to just give me a break that, there we go. I want to do a flip left, right, and now I move it over here, and do you see how a left-right flip pretty much replicates the other side? All right, so these are all left-right kind of flips. These are all even functions. Doesn't this one sort of look like a parabola? It's not, but do you see how it sort of looks like one? So a parabola would also be an even function. Yes, that has an x squared in it, but does that mean everything with an x squared in it is always even? It is not. Not everything with x squared in it is even. So don't trust the little power to tell you if it's even or odd. The pictures are fairly easy to see if they're even or odd. All right, those are all even ones. So here's some odd ones. Do you see how you can't just flip them over left, right? But can anybody see a pattern? You could do something. Come on, I want somebody to notice this before I say it. It's kind of like a rotation, yes. I want you to say it in terms of a flip, though. It is a flip, kind of. Yes, you got it. It flip across both axes. See, at first you flip like this one. Picture for me taking this part and flipping it, and then it flips over here, right? And then you flip it the other way, and you flip it up, down. And you flip it from here down to there, and it goes down there. So it's a double flip. It's a flip over both axes. Now, the way the book is going to say it is they're going to say, instead of saying a double flip, which I actually like a lot better, they say it's a flip over the origin. Okay? So they flip it and they go like that flips to that because everything is directly across that point 0, 0. But that's harder for me to see, like how this spot becomes a flip over this spot, because it does, well, it kind of does if you go like that. You see what I just did there? Okay, so it does work. If I take this point over a half and up 2, and I go right across the origin, then hits down there. So it works. So that way it works too. However you want to think of it, I like to think of it as a double flip. This one's the hardest one to see. Okay, and if I wanted to do that shooting across the origin deal and pick a spot, here's the origin, right? Here's the spot. I pick right there, over 2 and up like 0.8. Again, I go like this, and it hits that spot. I might be off a little bit there because I didn't draw a perfectly straight line, but there is a reflection, a double flip going on. If you want to see the double flip way to do it, I'll draw it in green first as a left-right flip. And then can you picture the green one flipping up-down? And if I flip the green one up-down, it ends up right where it's supposed to be. So either think of them as a double flip or think of them as a reflection across the origin. Are you with me? Do you get what I'm saying so far on odd even? Well, we'll find out. Don't say it. Their names are Bob and Sue. Who's odd? Sue. Bob even? Yep, it's a reflection across the y-axis. All right. An even function, how can you tell from the graph? Well, there's symmetry across the y-axis. Every point 1, 1 has a reflection at negative 1, 1. In other words, you just take if you stick in a negative for the x, the y doesn't change. If I stick in, I had a 1 and I get 1. If I stick in a negative 1, I still get 1. Notice y is positive in both cases. So I can put in 1 x or negative x is another way to say that. So how can you tell that algebraically? I'll show you the little formula in a second. The odd one, this one, if I stick in x's that are negative of what they used to be, then their y's will be positive. That's a screw up on my slide. Sorry, that's supposed to be a positive 1 right there. If I stick in a negative x, I get a positive y. Now, that's going to make more sense to you in a second. All right, right now, would you please write these down? These are old functions that you knew how to do last year. And I'm going to show you how to do some basic functions here, because this, if you can't get this stuff, you won't get odd even algebraically. Pictures are easy, but we don't do much with pictures. We do it mostly algebraically, kind of like that domain. The domain with pictures was pretty easy. Left, how far to the left does it go? How far to the right does it go? But domain algebraically, more complicated. All right, so write this down. What is f of 3? Well, that means you take this function, 2 times whatever the x is, and then minus 4. Notice how I wrote that with an empty spot where the x is. This is a really smart thing to do. Then take whatever they tell you is x. See that right there is when they're telling you what x is. X is 3. You drop it into the empty spot. Now, that's so simple on this one, you might feel like, what's the point? I can just go 2 times 3 minus 4. Because if you write in the empty thing for the x, it'll help you a lot on this next one. By the way, this last one was 6 minus 4. It gives me an answer of 2. Do you get how f of 3 is 2? Stick a 3 in and see what you get. This one, this is the harder part. It's where you're sticking in a negative x. Again, you just write down the f function right there with an empty spot where the x is. Make that an empty spot instead of a x. And then drop in negative x. So what is f of negative x? You drop in the negative x and you now multiply it all out and see what you get. What's 2 times negative x? Negative 2x minus 4. Is that the same thing it was before? Or has it changed? It's different, right? That's what you do to tell if something's even or odd, is you drop in a negative into the function and you see what happens. All right, I'll tell you, you get more of that in a second. Is that different than the last one? The last one where I have a negative on the outside, is that going to be different? Yes, it is. That's how you tell the difference between even and odd ones. All right. This one is going to come out different. If I stick in a negative on the outside, then I have a negative, and then I need what f of x is. Well, f of x is right here. So I can drop that in. and I have negative in front of 2x minus 4. And we strongly recommend you think of this as a negative 1, so you'll remember to multiply it into both spots. Okay, so then I have negative 2x, and the negative 1 times the negative 4 makes positive 4. Is that the same as that is? No, it's changed. All right. Now, how do you tell if something's even or odd? You're not quite ready for that yet. We need you to be good at dropping in negatives. So everybody try these 3 and see if you get the right 3 answers. Here's your function. Drop in negative 2, see what you get. Drop in negative x, see what you get. And on the third one, see if you can just do the opposite of f of x. So on the first one, Mr. M, what'd you get? Did I say your name wrong? I'm trying not to say your name on the tape, so go ahead. What'd you get? All right, negative 8 plus the 1, making negative 7. Okay, how about f of negative x? You drop in negative x inside. Remember what I said was smart? Leave an empty spot. Get rid of this stuff. Leave an empty spot where the x is. And now I drop in what? This. Drop that into the empty spot, negative x. Negative x cubed means negative x times negative x times negative x, which makes negative x cubed plus 1. That negative sticks around because there was 3 of them. Is that going to be different than this last one? All right, we'll find out. Negative f of x means negative 1 times, what's f of x? What's this? That's f of x. So I drop it in right here. X cubed plus 1. And what's that equal to? Negative x to the third plus 1. I'm sorry, minus 1. All right, so now I've showed you a lot about how to drop in negatives into this formula. And why? Because here's how you prove if something is odd or even. It's not about what degree it has. That does not tell you whether it's odd or even. Now, that being said, when they are in their simplest form, that is even and that is odd. But all I have to do is like add 1 to it, and now it's not odd necessarily. Got to check. So how do you check? There is a rule, and it's right here, for odd things. If f of negative x is equal to negative f of x, then it's odd. Write that down. You will not naturally remember that one because there's too many negatives running around. It's like, was that negative on the outside or the inside or what? Write that down in your notes. Writing it down will increase the chances that it will stick in your memory. Don't make me call you out because you're not moving your pencil. All right, now the way I try to remember it, because the odd and the even one, the rules look a lot alike. This one is the only one that has 2 negatives. Both sides have a negative in it. And I say, oh, it's got 2 negatives in it. That's odd. I don't know. Remember it any way you want to remember it, but that's the way I try to remember it. All right. So to prove whether or not f of negative x is equal to negative f of x, I got to find f of negative x. Then I got to find negative f of x. And if they're really equal to each other, then I'll know that I've got an odd function. I already told you that that's an odd function, so we're going to still prove it, though, the official way. So the first thing we have to do is find f of negative x. Remember how I said if this is your function that you use a negative or an empty parenthesis cubed, and then you drop this in. And f of negative x would end up being this. I just have to simplify this now, and I get negative x cubed without the parentheses anymore. That's important. Now I do this side. This is the kind where you do negative 1 times whatever f of x is. Well, f of x is x squared, or sorry, cubed. And then what's that going to be equal to once I get done multiplying it all out and get the parentheses gone? negative x cubed. Is this really equal to that? Aren't they pretty much identical? And I've proven that x to the third is odd. So on the test, do you think we just say, is x to the third odd? No, we say prove that it's odd, or that it's even, or that it's neither odd or even. All right? So that is a way of proving that something is odd. I want you to try that with me again with x cubed plus 4. That's my function. And now to prove that it's odd or even, to prove something that is odd, you start with this. If I want to prove it, if it's odd, I'm going to see if it's odd. And if it's not odd, maybe it's even. So I write down the little thing. F of negative x is equal to negative f of x. You just have to memorize it. That's why I had you write it down. Now, I'm going to draw a line like this. And I'm going to figure out f of negative x on this side. And I'll figure out negative f of x on that side. And I'm going to see if they really equal each other or not. If they equal each other, then this will be proven to be odd. All right, so now I'm going to take this little f of negative x. So I take this equation. I write it with an empty spot. Then I drop in negative x. And now I've got negative x to the third plus 4. On the other side, this is the kind where you go negative 1 times f of x. And I drop f of x in the empty spot. So this goes down in there, and I get x to the third plus 4. Multiply it out, negative x to the third plus 4 is, oh, I messed it up. That's the really important part. Is this actually equal now? No. So is it odd? No, it's not odd. Am I done? No. Now I got to check for even. But you don't know the rule for even yet. But at least you've proven that this isn't odd. And I warned you, just because it has a little to the third in it does not mean it's odd. All right, it's got a proof. All right, next thing that we show you is how to prove something's even. If this is different now, it starts the same. If f of negative x equals positive f of x, as in normal f of x, then it's even. Write that one down. That's the proof something's odd. This is important. This is an R3 level question. Of course, this one itself is a really simple one, but this skill of showing if it's odd or even, that's the A and B type level question. Got to answer these right to get an A or B. All right, this one's pretty easy because it's just x squared. So I start by figuring out f of negative x. So I figure out this squared. I drop in negative x into the empty spot, and then I multiply it all out. And what do I get? X squared. I go over to the other side. F of x, well, that's not too hard, is it? In fact, that's extremely easy. F of x is given to me. So I just write x squared. Now, did that turn out to be that? Yes, it did. So what did I just prove? I just proved that f of x equals x squared. That function is even. Because these were equal. So it's even. All right, now, how are you going to tell these two apart? The odd one has 2 negatives in it. Oh, that's odd. Notice that the rule for even and odd look identical to start with. And even the f of x is identical. It's just one has 2 negatives in the rule and the other one doesn't. Can you try to remember that? I hope you can. That's what you have to keep straight. Because once you get what you're doing here, you just got to remember the rule and then prove whether it's really true or not. So which rule is this for? Odd or even? That's the odd one. Did you notice the 2 negatives? Is that how you did it? Okay. And this one's the rule for what? Even. Notice they start the same. All right. So let's do a couple together. And I think this will come together after we do a few problems. So to do this, you'll need your book. And it starts page 102. The first few are pictures. Those are easy. So I don't even want to try messing with those. I'm going to do 47 with you. And number 52. I think 47 is the first one I want to hit. Okay, so please find page 102, number 47. If you don't have your book, which I understand, grab your book, grab a book from over here, leave a shoe or a cell phone. Do not take it without leaving a shoe or a cell phone, or you're stealing. Please don't do that. Yeah, that chapter's done. You can recycle that one now. Uh-oh. I think I have one. I have one more. I haven't checked this one in, though, so hand it to me personally, okay? Because it's somebody who left the class, and I haven't checked it in for him yet. Okay, number 47. Here we go. Would you please read me number 47? Miss D? Read it. Okay. So just read me the problem, number 47. All right, we're going to figure out if that's odd, even, or neither. Now, there's two things. You could test for odd or you can test for even. Wouldn't it make sense to test for the easier thing first? Because if it works, by the way, even is easier to test for because one side of the even proof is just f of x. So it's really easy to test if it's even. If you test if it's even and it is even, you're done, right? Because it can't be even and odd. So you might as well test the easy one first. So let's test that. So let's test for evenness. The even test. Do you have it memorized? How does it start? F of negative x is how they all start. And then e equals what? F of x. All right, that is not going to be given to you on the test. You have to know that. Okay, now, to prove whether it's really even, I got to do both sides of this and see if they're really even or not. So, this side, f of negative x. Well, I take f of x and I leave an empty spot where the x is, and I drop in what they told me to drop in, which is negative x. When I actually multiply that out, I get 2 times negative x times negative x times negative x times negative x. Is it going to be positive or negative x with stuff? Positive x. So it's x to the 4th. All right. Now, the other side is just f of x. Can't be easier. They already told me f of x right there, so I just write 2x to the 4th there. Is the left side equal to the right side? Yes, it is. What have we proven? That it's even. Is there any sense in testing anymore? No. It can't be odd, and it can't be neither, because it's even. So I'm done. I've proven it's even. Okay, so if you write that down, you've proven number 47 was even. Now, there's a few more easy ones in here. I want to hit number... wouldn't you read me 52? Would you read me 52? Okay, that's an ugly looking function. Should I start testing for odd or even? Well, always start with even, just because it's easier. Because it might be even. I know it starts with an x cubed, but that doesn't mean it's not even. It can be even. All right, so now I'm going to test for evenness. F of negative x is how they all start. Equals f of x. I'm testing for even. I'm going to drop in a negative x in here. So in all my spots there was an x, I just put an empty spot. And now I'm going to drop in a negative x here and here. And now I'm going to get negative x cubed plus, and that negative will cancel off, 0.04x plus 3. Okay, now f of x, again, that's just recopying the function. X cubed plus 0.04x squared plus 3. Is this exactly the same as that? No. So therefore, what have I proven? It's not even. Does that mean it's automatically odd? Nope. All right. So what's the test for odd? I'm going to do that in blue over here. The test for odd is f of negative x equals f of x. Now here's the cool part. You've already done half the work. Do you get how I already figured out f of negative x over there? Why do it all over again? I already know what f of negative x is. See what I'm saying? I'm just going to take it. It's right here. And I'm going to put it over here and say negative x to the third plus 0.04x plus 3. But oh, wait a minute. I screwed up my odd rule, didn't I? Sorry. My odd rule has a negative right there. There should be 2 negatives in the odd rule. Sorry about that. That hadn't affected me yet, but I'm about to do it. So now I got to do this side. That means negative 1 times f of x. Well, f of x is given to me right here. So I just put in x to the third plus 0.04x squared plus 3. And now I multiply this out. Negative x to the third minus 0.04x minus 3. Do you get that this is not equal to that? So it's not odd. If it's not even and it's not odd, guess what it is? It's a neither. Okay? That's how you prove things are odd or even or neither. Yes? Well, if you think about the pictures, most things are not odd or even. You know what I mean? Like if I'd go like this, and the function over here goes like that, then it's not odd or even because it doesn't have nice symmetry. So things that are odd and even are actually kind of rare because they have to be perfect. Like this has to have a perfect match over here to be even. And in a picture that's odd, if I have something like that, I'd have to do a double reflection to make it odd. So I'd go like, there's the reflection of up and down, and then I go reflect down here and go there. It has to be like that to be odd. So it's actually tough to be odd or even. So many things will be neither. Okay. So you've learned what you needed to know. The assignment I should probably put up right there. It's page 102, 41 through 54. And tomorrow I'm teaching you something that will take about a little less time, I think. It's about asymptotes, or maybe the same amount of time. But if you're gone tomorrow, make sure you watch that video and stay caught up on that. I'm going to tell you the homework just in case you're gone. Let me see if I can find it. It's right here. Homework is right there for Wednesday's homework. It's page 103, 55 through 62, 67, and 72 to 76. So if you think you're going to be gone tomorrow, you may want to write that down. Otherwise, you have, well, I'm going to say it at the end of the video tomorrow too, but 103, and this looks like a big assignment, but it's really only like, I don't know, 10 problems or something like that. It's not very many. I guess I can figure it out. I think that's actually 14 questions, but anyway, but that's not that bad. It looks way worse than that. And a lot of them are simple, like, here's a picture. Is this thing odd or even? Or neither. Tomorrow's has got more other stuff on it too, like the stuff I haven't taught you yet, horizontal and vertical asymptotes. All right, so anyway, that's what's going to happen for the next couple days.